number 94, binary tree in order traversal. So we have the binary tree, and then we have to return the in order traversal node values. So what the in order traversal is mean that we have to go from the left of the tree, then we go to the middle, and then we go to the right. It's mean in our traversals. So for example, if we have the binary tree like 5, 3, 5, and 6, so the first thing we want to do is move to the left first. So we move to the left, which is 5 right here, and because 5 right here is none, so our output we want to return 5 first, because this thing is none, so we want to return middle one, which is 5, and then we go to right, but because right is none also, so we want to return the middle one right here, which is 3, and then we go to right, 6. So we have 5, 3, 6 in this case. For the examples, we have 4, 5, and 6, and right here we have let's see, 8 and 10. So again we go to the left, but because the left of the 5 is none, the 5 is none, so we want to return 5 first, and then after we return 5 we go to the right, which is 8, and we saw that the left of 8 is 10, which is not known, so we want to return 10, and here is known, so pass it. We go back to 8 and we want to return 8, and again right of 8 is known, so we go back. After we go back, we see that we have already returned to 5, so we will return 4 in this case, and because 4 right of 4 is 6 is not known, so we return 6 too. So this is our output. Okay, so here's the solution for this problem. So I have solved it in Java, but I want to test it in Python, so I just figured out how to implement in Python like 2 minutes ago, so I will explain it. So in here, let's see, we have 1, 2, and 3. Okay, so first we want to go to the left, like we go to the left. If we have like this, we want to go to the left until the left is none. So it means we will use the recursion to call out our function to run until we are at the end of the left root. So we will return this, we will return a number, and then we go right. So if right is half a number, we continue, but if the right is none, so we want to go back to the middle one right here, and then we return number 2. So we return number 2, and then again, because right here is don't have the value, so we want to return the 1, and then we go to 3, and because 3 the left of 3 is none, so we want to return 3. So it's like this. So let's implement it into code. So first thing we want to declare our output value. So we have I think we have to use the init for the class in Python. So we call here is output list equal the empty array, empty list otherwise, and then we want to the if we want to have the condition for our recursion, so we call here if root equal none, which is none in this case, so we want to return. And then we want to move to the left, so we call the function again. We call the function and we move to the left, so we will move into 3 here, and because the left of 3 here is known, so we want to return 3, so we will add the value of the left here, so we have root left, and then we want to go to the right, so we have wait, what? Right. So left, we hit right, so if our right is none, so we want to return again, in this case 3, so we will add the 3 here into the list, and after we go through the recursion, just return the cell input and then check. Oh yeah, I forgot. This one must be valve, not left. Sorry, my mistake. So let's run again. Okay, there we go. Okay, time for analyzing. So we have time and space. So because my code is using recursion, so we have to use stack for recursion, so we have here a recursion stack which is cost pick of n in the worst case, so we call pick of n, which is the binary tree of this, and we have the output list which is cost on elements for the tree, so we have here is n plus n, so we have O of n space, and time, because we want to go to each value in the tree, like we have to go 5 and 8 and 10 and 4 and 6, so we have to go through all of the value in the binary tree, so it will cost big of n time complexity in total. Okay, so analyzing. Okay.